This is a quick follow-up to the video I posted on the TI TMS320, specifically the F28035 that I'm using here on this little PCB. At the end of that first video, I mentioned that the code I was writing to the flash using this debugger here, when I would remove power from my MCU and reapply power, that code would not run. And the question I had was, well, was the code still there in the flash, or did it not really get written to the right spot or something like that? Or did I have some configuration option not set correctly? And so there are some certain pull-ups that I mentioned last time that I thought were correct. And as I turned this back on, it would not run. But I can show you now that if I apply power, you'll see it does automatically start running that code I had before. And I'm accustomed to working with MCUs that when I program them with the software and the programming device like this, that they persist and then they just naturally boot back up to that. That is not the case for this MCU. And I actually found that there's quite a few steps that you need to go through to take a simple flashing LED project like this and get it written to the onboard flash, in the MCU itself. But I'm going to walk through the basics of that at a very high level, and I'll show you really what I was working off of as far as resources to make that happen. So over on my desktop here, go out to this blog post if you are interested in working with this MCU and you're trying to figure out how to get it to boot up to a program in its internal flash. What I found that really was helpful is a link out here to a workshop, and this is out on ti.com. And when I go to that, it basically takes me over to this exact page right here. And so they have all these different resources, and this is really great. It's organized well, and there's all kinds of good stuff here. But there's a C2000, which is the processor or the microcontroller I'm using. And there's the C2000 Academy, and within that, you can get down to the Gen 2 and Gen 1 devices and find an F2803X workshop. And that's what I have a link to directly on my blog post there. But in that workshop, you can grab this file, and I'd recommend you just grab this and you run it, and it will install three things, or essentially extract three things for you on your drive. One is a manual. It's kind of like a student manual for this workshop. And then there's also some lab files if you want to go through the labs that are in that, the manual and the video that goes with it. There's actually quite a bit of content for it. Or you just want to open up the solution files. And what I found myself using was this manual plus the solution files, and that was quite helpful. And over on my blog, there's a fair amount to this, but what I did, let me just refresh this page here. I did add some basic instructions to kind of see how I went through this. So I'll get back down to that, and I added this number 7. So this is down within the section on this specific MCU. I've posted the first video, and when I'm done with this video, I'll post the second video, this video directly after it. But I added number 7, and this is to write a program that you've built into the flash for standalone operation, meaning I don't need this debugger hooked up. I can just power on the MCU and have it run. To do that, I continued with the project I had from the last video, which was just this simple flashing LED sample. Then I had to replace a linker command file, and I'll walk through this over here as I do this. So in the project I had before, what I had was a command file, and there's a couple of them that I had. There's a CMD, and this is an example of one that basically is a linker command file, and this is one that was in the project. And in addition to that, I had a different one that looked like this. And this file basically is setting up memory spaces and then where my different code sections from my code will map and get placed in those memory spaces. And that really is going to help the system know, is this in some type of SARAM or is it in Flash or something other. But I renamed the original one. You can see here it's called CMD_orig. So I changed the name of it and I put this file in its place. Now this file I grabbed from the Lab 10 files. So as you go through Lab 10, what you're going to find is that they give you a nice workshop book like this, kind of a student guide. And if you scroll way down in that, you'll get to the 10th chapter. And on page 10-9, there is some information about Flash programming basics and the idea that the processor itself is what updates the Flash. And so you got to go through a whole bunch of steps to get this done. And this will walk you through that, at least from a teaching perspective. And you can use the files that are provided with the lab to really do it step by step. But I started with my project, not necessarily their entire project. I wanted to take this flashing LED and get it written to the onboard flash and bootable to that. So some of the files I'm using are different than what they point to in the lab, but that's kind of why I put some of the basic instructions here on my blog post. But this first one, the linker file, I took their linker file from the lab files that I downloaded and pretty much just pasted it in here. And what this does is it set up a new space that points to where the flash is on the MCU and its address space. And then it maps a whole bunch of things to say, you know, all of your basically your .text sections, which should be like code sections, should be in that flash space. And there's other things that should be there, but then there's some things that shouldn't be there. For example, the actual programming of the flash, you don't want to do from the flash. That needs to be done from RAM. This is how I understand all this, at least. So they kind of walk through that. So I had to replace that file. I then had to make sure that I was initializing this thing called PIE and have the right actual code that does the flashing. Now in the lab, they have you bring in a file that has that. But what I found is in my sample project I was already using, I had the right files for these. The specific flash functionality is in this file called syscontrol. And in it, there is basically a code section that I want to make sure that this is in what's called secure RAM funcs. It's a certain spot in my memory addressing. And then I come down here and there is a procedure for init flash. And then there's some code in here that actually will help me with that. You know, anytime you see some of these are assembly calls, and you're going to see that you actually have to put some assembly in here to make this work also. If I go back here though, after, you know, I have that, make sure I had that flash file in there. In my case, it was part again of this syscontrol file, or you bring in the one maybe from this lab 10 if you want to use this flash.c. And then there were certain things that had to be done or verified in this PI. There's an init PI control. Now in mine, that was in a file that was already in my project right here. And then there's code for this init PI control. Just things like setting up all my interrupts. Interrupts have to be copied into RAM, basically when the system boots up. So all of that complexity has to get taken care of here. And I'm not great with all the details, but I was able to follow through the lab and kind of find those appropriate locations within my code, do some tweaking. There were a few other little things along the way that I had to tweak that maybe don't show up exactly the same or with all the detail in the notes here. But this, between the short notes I have here and that lab manual, you'll be able to get through this. Then I had to go into my main function. So in my case, my main function was in this LED blink. And inside of my main, I do things like this init syscontrol was there before, init this PI control, PI vector table, CPU timers, configure the timer for how fast I want these LEDs to flash, set up the registers for the LED control. But then I had to put in some additional code here, And this is really copying appropriate sections from flash into RAM so that certain things can run from RAM that need to start from RAM. And that's really anything that's in this code section called secure RAM funcs. But it copies that over and then it calls this initialize. So initialize the flash. Then I also added a passwords file to my project. And basically this has to do with if you want to lock the MCU down. And I left all the passwords at the default, which is all Fs. So FFFF for this first password, et cetera, et cetera. I'm not worrying about locking this down. If I change these, then if I want to ever get into it later, I'll need those passwords that I put in here. And if you put it to all zeros, it permanently locks the device. So there is no, kind of going back into whether it's, I don't know if it's just the writing of it or the editing, debugging, pulling code off of it, whatever it might be. And then I also had to bring in or make sure that there is some assembly code, and the lab uses a different file, but in my case, that was already here as part of this code that I had started with. And so there's some assembly. Basically, this has to run because it can't start with C code, and the way that this whole boot up initialization process works, you kind of have to bootstrap it from some assembly code here because it jumps to a certain location. You get a one-word, 2 bytes to say where you're going to jump to, and then this is going to jump to the start of really where all the C code starts running, which would be my main procedure back in this C file over here. And that would be, again, back up at the top of this. So you get through all of that, and so that was a lot of steps. Now that I've done this once, I kind of have a template. I can, copy and paste this project and then modify from there. But it seemed like that was a lot of work just to get this so that I could use the debugger, write it to it, and then when it runs, it will get that flash copied over. And so that is working now, as you can see. So I can now power this off, power it back on, and that program that I had from the first video is what I put in here, and that is running just fine. And I still can turn it off. I can still plug in this header here and debug it still. So I can still debug it, do all of that. I can still reprogram it if I want. Now, when this is plugged in, it changes the boot behavior so that it doesn't boot straight to flash. Instead, the emulator can control how it boots and how I can debug and work with it. So 2 different configurations. When this is either plugged in, it works one way. When this is not plugged in, it's going to work a different way. But that's all I had for this video. So not too long of a video, but I just found that I had to do a lot of digging just to find, once I got to this workshop file, and I'm sure there's other documentation that covers this, of course, somewhere, but I found the content that this lab walks you through is quite helpful. And that was enough for me to adapt my existing project to get all of that up and running. So maybe, again, this point forward might not be so bad, but the first time doing this, it just seemed like a lot of work for something really simple as I just want to boot my MCU to the Flash program, the program in Flash on the MCU. I do have links down here, again, to the workshop. It'll take you straight there. If you want to play with that, if you happen to have this MCU that you're working with. And I did also put in a copy of the schematic for this specific board that I'm working with so far. So thanks for watching. Hopefully that's helpful for any of you that might be deciding to tinker around with this MCU.